Okay, hello. If you're watching this movie, then you're probably on YouTube, on the Durisol UK YouTube channel, and there's a variety of clips and short pieces on there about building with Durisol. This is a bit more in depth, so if you want to have a nose around, you're thinking about using the system and you want to understand a bit more about it, then this is a typical webinar material that we deliver for an introduction where we take Q&A in a live webinar forum. But I thought I'd record a version of this and put it on YouTube so that at your leisure, if you're thinking about using this and there are questions that you have, that it may help answer some of those. So like I said, my name's Neil Bussey. I'm the Managing Director for Durisol UK, down in the window here, and I've been running the company for a couple of years now. I'm an engineer by training, and we manufacture here in the UK. We're a global brand, so we have manufacturing plants around the world, and they're used to manufacture Durisol for a variety of applications. Here we use it for house building, for units, for construction, and like I said, we manufacture locally, so we're fully in control of the process, and we're sourcing all our materials locally, and I'll touch on that in a moment. So we are predominantly, and the origins of the business has been around house building. So we've been creating grand design houses for many years. This one, for example, was on Grand Designs The Street show in 2019. It's a Graven Hill in Bicester, and this was an award-winning ICF home. You can't really tell once it's been covered up what it is. It could be any sort of system under there. But this one and the one next door are Durisol builds. And an ICF system, an insulated concrete formwork system, and there are a variety of systems out there, is designed to create a monolithic concrete frame within an insulated formwork. And there's huge benefits there in terms of a thermal mass structure that's insulated. It's very stable, it's very strong, durable, it's got great junction details in terms of air leakage and thermal leakage, and it gives you a quiet and nice temperature regulated home to live in. And they're also, from a construction point of view, very quick and easy to construct with. So there's a variety of benefits. Now you can make them look modern, or you can use quarried stone, and you can use other materials local to you to actually fit in with the whatever the local styles are. So whether you're in the Cotswolds or in the Fens or wherever you happen to be in the UK, you can marry the Durisol construction in to look like whatever you want it to look like. So there's good flexibility with these systems as well. Just some renders of what we have been involved with and what is possible, just to give you a flavour for it. So we're not really fixed and stuck with a particular style. Now, the origins of the business, whilst the government now wants to create 300,000 homes a year, but doesn't seem to have the traditional build materials in the quantities required to achieve that, or indeed the trades in the numbers that are required to achieve that. These modern methods of construction and alternative methods now have an opportunity to fill that void. So whilst we've been involved heavily with self-builders predominantly, we're now transitioning and starting to get more involved with commercial and retail, and with major house builders and developers as well. The reason that it's been appealing in the past to self-builders and continues to be appealing to self-builders is this is a genuine self-build material. So it's a dry stack system. If you can run a line and a level, then this is a system that you can actually construct with. And there's a community on Instagram, and if you go online and you search, you'll find people who are building with Durisol themselves, and hence saving money and time that they would otherwise be spending on professional contractors to do what are designated as self-build projects. But we do get involved now in retail and in civic buildings, in schools and libraries and other structures. Anywhere that you could potentially use a concrete frame, you can use Durisol. So this one's interesting. For example, this is a library. We have a cantilever here opening over the main entrance, and that's something that's very difficult to create in masonry. However, with concrete, with the option to reinforce it, you can create interesting architectural details like that as well. The origins of the business, the company was, or the concept of woodcrete was patented in the 1930s. So the method of making the material has been around for a long time. It's been used extensively in mainland Europe, and it's now used extensively around the world. In terms of in the UK, not really for very long have any of the ICF systems been operating here, but they're all growing rapidly now. So, like I said, this is one of the systems that is going to fill the void and become a more mainstream market player in the next few years. So we manufacture worldwide. The production facilities making acoustic barriers and other things from woodcretes as well, which sit in the elements exposed permanently. So I'll explain about the characteristics of Durisol and how it performs in a moment, and why that should give you some confidence in terms of building houses with it. Jump on here. So we manufacture in an unheated factory in South Wales, and we bring in wood chip. This is softwood from recycled sources. So this is predominantly pallets and cable drums that have been chipped down, and it's important we get the right grading of wood chip, and the percentage of different chip sizes in here is very critical to the process. In its naked state, this material is not particularly desirable for constructing houses out of. Softwood, it burns, it rots, it supports moisture, and so it has some fairly unpleasant characteristics in terms of making houses out of it. So what we do, and the system and the process that was patented back in the 1930s, we take a mild chemical solution. There's nothing harmful in here, but it's a proprietary mix which we dose the wood with, and that just neutralizes the sugars and the proteins in the wood and makes it inert. Once it's inert, it doesn't then burn, it doesn't support capillary action, it doesn't present as a food source to wood-boring insects, and it doesn't do all of the unpleasant things that it would otherwise do. Once we've done that, we can then form this into blocks. So we have a block laying machine, it presses them out on the floor. Like I said, it's completely unheated factory space here, and once they're pressed out, we allow them to cure under plastic, and the heat generated from the reaction with the SEM1 in there is enough to heat the factory space. Once they're cured, we then trim them as well. So these are dry stacked units, so they're designed to be built without mortars. So it's important that the tolerances on them are tight, and that we build them with good dimensional tolerances. Thereafter, we insulate them for external walls, or we leave them uninsulated for internal walls, and we pack them and we ship them out. So it's not an easy process to perfect. It's BBA audited, and the quality plan is quite exhaustive, but it's actually a very simple process. It's just about getting all of the relative humidities and the moisture contents and everything absolutely right to make it work. What you have in a finished material is something which doesn't burn. So there's a European technical approval attached to Durisol, and it's A2 rated in there. So it doesn't burn, and that satisfies all the requirements for constructing in the UK. Other properties that it has, it will not rot, which is great. It means you can build below ground, you can build swimming pool bases with it, you can build retaining walls and never finish it on the outside and just leave it exposed. It will not degrade in the presence of moisture. And it doesn't support capillary action either. So most build materials will suck moisture up. If they're sitting in a body of water, they will draw material up water up through the material via capillary action. Durisol is a very open matrix material. There's a lot of trapped air in these units, and it's insufficient to support capillary action. So you get a little bit of creep, like an inch or so, if you sit it in a body of water. But most build materials will see water tracking up many meters potentially, which is why you need damp-proof courses in there to prevent moisture travelling up from the ground. Now, we do put damp-proof courses in because we're filling these with concrete, and concrete does have some capillary action. However, in terms of building a solid wall, having a material that doesn't support capillary action is very important, because it means that you don't get any moisture from the outside drawn inwards to where you don't want it. And historically, we've used cavity wall construction to achieve a moisture break within a wall, but it's quite onerous in terms of building the structure twice effectively, whereas a solid wall construction avoids any need to do that. I mentioned that it's resistant to wood-boring insects, so the pH of the final material is alkaline. It doesn't present as a food source to wood-boring insects and termites and the like. I'm not sure how relevant that is in this country, but certainly around the world that is quite a key characteristic. And it's fully breathable as well. So the material's not waterproof, it's porous. It will dewater the wet concrete that's in it. But the fact that it's breathable means if you leave it exposed, then you'll have a breathable wall, or if you use a lime render, lime mortars, it would breathe. If you want it to be fully sealed, then you can put wet finishes on it, or you can put house wrap membranes, and you can mechanically ventilate. So there's options there in terms of breathability, using the wall as a breathable material, or having other arrangements in terms of your ventilation. I mentioned the high recycled material content, so that's an important characteristic as well. So what this offers you or affords you is low U values, so the thermal performance of the wall is very good. Junction details, because you've got a monolithic structure with very few component parts, you have great junction details in terms of thermal leakage around junctions, doors and windows, etc. That's all modelled independently, and it's in the technical manual. Good air tightness with the secondary finishes. If you put wet plasters and wet renders, you can get excellent levels of air tightness. Good acoustic performance, and also fire tested as well. So the company has sort of jumped through the hoops, if you like, to cover all of these bases. In terms of the range, it's very simple. So there is a 365mm unit, which the 365 dictates the thickness of the wall. 300, for example, is a 300 thick, 250 is 250, and 170 is 170. All of these units are 0.5 metre long, and they're all 250mm tall. Now, you don't need to get too hung up on that, because you can cut these wherever you like. So if your wall dimensions are not exactly in keeping with the dimensions of a unit, then that's easily worked around on site. You have the ability with these that whilst they are modular, whilst we're doing quite a lot in the factory of the work to create the wall, when they come to site, if you want to change things around and move things, you have the adaptability to actually just change these very simply. But we effectively have 2 units for external walls. The 250 is used for dividing walls between dwellings where you need an acoustic rating of 45 decibels across the wall divide. So if you're building a pair of semis, for example, then you could use the 250 to form the wall between them. And if you want to form your internal walls with Durisol as well and fill them with concrete, then we have a 170mm thickness. And that gives you the ability to bear floors and things onto internal walls, which you wouldn't otherwise be able to do if you were using stud walls and things like that. And it provides excellent acoustic separation within a house. So if you want to have that acoustic separation, that quiet enjoyment of your home, then building the internal walls out of Durisol is something that you could consider as well. Within the range, if you picked, say, the 365 unit or the 300, there's 3 types within that designation. So you have a standard unit, which is notched at either end, which we do in the factory, so that when you pour your wet concrete, it flows through and it connects these all together. We have a face unit, and this has a blanked off end. So the idea with this is that you offer this up to door openings and window openings, and you can form those reveals without the concrete obviously flowing through and pouring out into your door jambs. So we have a face unit for that purpose. And then corner units, which is fairly self-explanatory, but we insulate so that you can actually run it around corners. And with these 3 units and adapting them where you choose to, you can build off your foundation all the way up to your gables if you so choose. So in terms of flexibility, the system is a dry stacked system. There's no mortars involved. You may want to mortar the first course down onto your foundation if the foundation isn't perfectly level, and you can easily do that. But thereafter, it's designed such that you don't need to mortar the joints. So that helps to speed the system up. There's 8 units per square metre, and that's forming the full thickness of the wall. So you've got you're looking at an inner skin and an outer skin. It comes pre-insulated. So in terms of a commercial developer building with these, an operative should be able to stack 200 units a day, which is about 25 square metres a day of wall constructed, which means that 2 guys should really be able to build the envelope of a 3-bedroom house within a week or so. It's really a quick system. That's done in any weather. Like I said, you can go below DPC, where you would normally perhaps be using a trench block or something like that off your foundation. You can go straight off that in Durisol. Doesn't necessarily need to be insulated below ground. And you can build up to 2.5 metres freestanding per concrete pour, which 2.5 metres represents a single story. So that allows you then to sort of pour a single story at a time. There's some bracing details that need to be taken into account within the technical manual, using some plywood to screw onto the units to brace the corners. But it's not particularly onerous, and it's all laid out in the manual. In terms of the quantity of concrete that you will need, 1 cubic metre of concrete will fill 10 square metres of Durisol wall with the standard configuration of insulation. It's slightly different for a 250 internal, and we do different configurations below ground. If you may want to have the units completely uninsulated, in which case they're going to consume a little bit more concrete. But again, that's all covered in the technical manual. And they're adaptable on site, easy to cut, and easy to adapt as you so choose. I mentioned you can build in any weather. This is a job in Reykjavik, which is currently underway as I write this, being built over the winter of 2020. And they were able to construct this in very cold temperatures and pour concrete down to -6 degrees, because it's going straight into an insulated formwork. So they weren't held up with the wind or the rain, and then they weren't held up with the temperatures either, which would otherwise affect traditional build methods. So for commercial developers looking to keep their builds on program, with a system like Durisol, you know that you're going to be able to build in any weather, and you're not having to think about lost time and your prelim costs and everything else ticking over whilst your labour is not actually on site. So we have material on YouTube, which you've probably already discovered if you're watching this movie. Supporting that as well, we have a technical manual on the website. So if you go to the Durisol website and you click on the technical resources tab, then you can find the technical manual and build guide here. I think you register your details and then it'll give you a password to download the document. It's a couple of hundred meg, so it's too big to be emailed to anybody, but it's there, and that goes in much more detail in how to cut and shape and adapt the units and to build with them, and all aspects of building with them are covered within the manual. But in essence, what you have, the green here is the concrete. So when you pour this in, you create a monolithic concrete frame. It flows between the units through the voids, and it joins together, and you end up with a concrete frame which is flowing through the whole structure. So that's extremely strong, extremely durable. It creates a high thermal mass within the Durisol units, so that actually soaks up heat and releases heat, which helps to regulate the temperature within your structure. And when you read about thermal mass, it's advantageous to put your insulation on the outside. So our PIR insulation, which we insulate the units with for external walls, goes on the outside of the concrete frame. So in temperate climates like we have here in the UK, where the temperature may fluctuate through 20 degrees or more during a 24-hour period, having an insulated concrete frame prevents that swing in temperature on the outside being translated onto the inside of your structure as well. Below DPC, you can have the units uninsulated. Obviously, we're manufacturing these as well as selling them and providing technical support. We are the manufacturers, and we have the flexibility to provide these uninsulated if that's what you want below ground. And we would see this as well in retaining applications as well, that it may be necessary to have uninsulated units where insulation is not important, but you need a thicker core of concrete to do more structural work. I can see here as well there is some reinforcement in here. So reinforcement within Durisol is something which is down to the structural engineer, but you can insulate them fully, vertically, horizontally, or you can have them uninsulated. And with house construction, it's quite common that we would have a house with very minimal reinforcement. There are situations where you would only have it in the lintels over the doors and windows. So here, for example, this is quite a small diagram, but we've soldier coursed the face units, we've stood them on their ends, and it creates a void which we can thread rebar through prior to pouring, and that means we can then form a concrete lintel within a concrete pour rather than sourcing a separate lintel. And I think there's some photographs of this here. So again, this will all be in the technical manual, but you can build up timber goalposts to sit your units on, and then if I look in from the end, you can see here we've threaded some rebar through just to indicate what's possible, and then that's overlapping either side of the opening. In this case, 250 mil. But again, it comes down to a structural engineer specification as to what size of opening we're looking at. Here, it's just a single doorway. If it was going to be a big 4 or 5 meter bifold doors, then it could be a little bit more onerous, and we'd have to look at a different configuration of rebar. In terms of integrating floors, you've got a concrete frame within the Durisol blocks, so that the units themselves, they look like masonry. We don't publish the compressive strength of the Durisol units, and from the perspective of a structural engineer, we would ask them to disregard the strength of the unit and actually just concentrate on the strength of the concrete frame within it. So then if you're putting on a plank floor or a beam and block floor, you look to bear this directly onto the concrete core within the Durisol. And that's how we would address big heavy floors like concrete floors. If you're using a more of a lightweight system like a timber floor, which is quite common with house building in the UK, then what you can do is you can actually bolt a wall plate onto the inner face of the woodcrete, and you can bolt through into structural concrete, and then hang joist hangers and create your wall your floor joists in the normal way with joist hangers. Which I find that carpenters tend to prefer to use this rather than try to individually locate joists. By putting a wall plate on there, putting a laser up and actually putting the wall plate on with the joist hangers, you have one operation for levelling the wall plate, and then all the joists are going to be level. So that tends to be something that they like as a process. What this means really is that you can then create quite extensive properties as a self-builder or as a developer very quickly and easily, and with a lower skill base in the workforce than you would otherwise need with qualified brick and block layers. We tend to find that carpenters are good with constructing Durisol units. It's very intuitive for carpenters in terms of bracing, ground workers in terms of pouring concrete. So there's a variety of trades who could extend themselves and actually build whole houses by having Durisol in their armoury. And these are the sort of houses that you can create quickly and easily. I can see here there's internal walls being built and being spanned onto as well in Durisol. And you can create quite grand structures then. This lends itself well to housing association schemes with simple boxes, but it also lends itself to quite grand schemes as well, and creating interesting architectural details. So it is quite a flexible material, applicable to a wide audience. In terms of the finishes, I think I showed some photographs at the start, but we can use cladding, we can use render finishes, brick slips, stone slips, and these might be acrylic and synthetic, or they may be quarried stone, as in this situation here. And we can fix these, we can bond them onto the Durisol, we can build outer skins. There's a lot of brick slip and stone slip manufacturers out there now, but we've also worked with companies who are using locally quarried stone, and we come up with solutions for how we can create slips from those and bond those onto the Durisol. So it really comes down to the preference from a structural warranty provider and building control as to what they're looking for, and we can have these discussions up front with them. But we have solutions across the range of finishes to satisfy them and to create a structure which is working, which is weather tight, durable and aesthetic as well. Now it mentions here as well about dot and dab plasterboard or finishes internally. So the Durisol, once you get your hands on it, it's a rough material, and it provides a great key then for a wet render or a wet plaster internally. So you can wet plaster directly to it. And the advantage of wet plastering to it is that you can hide your surfaces in the depth of the woodcrete before you actually get to your concrete core. So you can actually run a router down the wall, and you can chase out for cables and for socket boxes, and you've got 40mm to play with before you actually get to your concrete core. So it's very, very easy to actually chase that out and provide space for surfaces and have a nice wet plaster finish. Or you can dot and dab and then run your surfaces down behind that. It's neither here nor there to us. And the advantage again with plastering directly onto it, because it doesn't suck moisture, because it doesn't support capillary action, your plasterer gets more working time with that plaster. Whereas if they're plastering onto a concrete block, the block is almost certainly sucking moisture out of their mix very quickly, and it's stiffening up. So they're continually wetting it down, wetting the boards down, wetting the wall down to give them working time to make that plaster finish nice. We also do retaining walls, so if you want to build retaining structures in gardens or more extensive retaining structures, then we can go up several meters. Obviously these are going to involve reinforcement and need to be designed by a competent structural engineer, but as compared to traditional shuttering, this is much quicker and more cost effective to create retaining walls, either in basements as part of a main build or as a freestanding retaining wall. And we have design information and charts and information that's available to engineers to help them make decisions. Every retaining wall needs to be designed based on the specific site conditions, but we have done a fair bit of the legwork, working in conjunction with friendly consultants that we know and work with to do most of that for engineers before they pick it up and run with it. And you can see here, this is what a typical retaining wall in Durisol would look like. So you have your foundation, and it's tied together with your reinforcement, but it just allows you then to have a permanent structure for your formwork above ground. The Durisol can sit in the elements, that it doesn't, it's not bothered by the conditions that it's sitting in, or you can finish it to make it look aesthetic. You could render it and you can put stone or whatever you want onto it. That's really, again, up to you. So why choose Durisol? Let's move my head out of the way again here. So it's a fast construction process, 8 units per square metre, which is very quick to build with. So that therefore provides labour cost savings either for self-builder or for commercial developer. Certainly, if you're a commercial developer and your site is running and you've got your your insurance costs and your security and your welfare facilities and all the other things that are running, that you want to be able to get onto that project, get the thing done, and get off again. And so, not being held up by the weather and not having slow traditional trades that are going to take a lot of time to actually get these structures up is a big advantage. We do construction training, like I mentioned, so this video is no substitute for hands-on training, and we're happy to come to site, and we do training at the National Self-Build Centre and also at the factory for anybody who's close enough and wants to arrange a visit up there as well. I mentioned the thermal efficiency and the low U values. It's published in the technical manual. We have software outputs on that, and we have the thermal conductivity for the woodcrete, and all the component parts of a Durisol wall are published in the BBA certificate as well, and in the European technical approval. I talked again about air tightness and acoustic performance, and again it's all covered, but that is an advantage of the system rather than a drawback. Operating in the UK, it's very important that we're recognised by Building Control, so we're registered with LABC, with Local Authority Building Control as a registered detail. In terms of structural warranty providers, when we work with Premier, the BBA certificate has stipulations in there about what NHBC are looking for, but we have a whole range of warranty providers. They all have different criteria, so I would advise you speak to us before you engage one of them as to specifically what they're looking for, but we have long experience with all of them and can certainly help there. And from an insurance point of view and a mortgage point of view, we are a member of the ICFA, which is the trade association for ICF manufacturers, and we have a letter from the Council for Mortgage Lenders which recognises ICF as a concept, as a traditional a standard form of construction. So that means that mortgage lenders can then lend with confidence, knowing that their body recognises ICF, the ICF concept, as a standard form of construction. So that's all in writing. It only covers the ICFA members, who were all regulated by the trade association, but that again gives self-builders and developers the confidence to know that anybody purchasing these homes will be able to get a mortgage on them. So we're British manufactured. That may be important to you, it may not be. Certainly through this coronavirus pandemic, we've managed to continue manufacturing as we're sourcing materials locally, and we're in control of our processes, which has certainly been an advantage for us. Generally a 4-week lead time, 4 to 6 weeks. It really depends how busy we are, but it's of that order. So if we're talking to you early on a project, then we can certainly factor that in, and I think that's a fairly good turnaround in terms of supply. Construction training, technical support. We have CAD details. We have other things that we can support architects and specifiers, structural engineers in terms of specifying and working with Durisol. Effectively, this is a concrete frame that's been created. So once you get the mindset out of thinking this is some sort of block work or system, but it's actually really just a traditional concrete frame, then everything else becomes quite straightforward with it. And we do a take-off service within Durisol in-house. We have in the office in South Wales. We can take drawings in, and we can provide you with a take-off of quantities that we feel it's going to require, and then a quotation on that basis. So hopefully that has given you some food for thought. Here's a couple of quick examples of some of the projects we've been involved with. So commercial development projects. This is a suite of townhouses. You can see balconies here and other interesting details. These are clad and rendered, which is very easy to achieve with Durisol. We've been involved with schools and also with passive structures. So this was the first commercial passive structure in the UK. It's the Interserve offices in Leicestershire. So if you go on the Passive House Trust website, as of the time of recording this, it's on there as a case study. I think you have to search for Durisol or search for Interserve maybe, but you'll find it on there as a case study. Again, it's clad, so you can't tell now that it's finished that it's a Durisol build, but that was using 365 units internally to form the walls. So we can go to passive. And we can create interesting architectural details like cantilevers and other things, anything that you could create within reinforced concrete. In terms of the concrete itself, there are low carbon solutions out there. There are solutions now that use pulverized fly ash and blast furnace slag as substitutes for CEM1. So if you want to reduce the carbon footprint from the material that you're filling the Durisol with, because the Durisol, the woodcrete, it is a recycled material. It's locally sourced. It's constructed in an unheated factory. However, you fill it with concrete, which traditionally is heavy on carbon. But there are alternatives out there now. There are these alkali-activated cementitious materials, and there are low-carbon alternatives within the concrete in the realms of ready-mix concrete now. So we have experience of that as we're working towards achieving a carbon-neutral walling system as a total wall. So certainly engage with us on that, and we can advise as to where we are in terms of the infill materials as well, and what can be used in conjunction with Durisol. Hopefully that's given you a bit of a flavour. I've rattled through it, but it maybe answered some of your initial questions. My details are here. There's an inquiry email on our website. We're on LinkedIn. We're on YouTube. We're on Instagram. We're all over the place. So you'll find us out there. So if you have any questions and you just want technical support and you want advice without being sold to, then please get in touch with us, and we can help. We can help if possible. Okay. Thanks for your time.